Welcome to Brain Vision.
So the question states that 6 moles of an ideal gas are used in a cylinder fitted at one end with a movable piston. The initial temperature of the gas is 27 degrees C and the pressure is constant. As a part of a machine design project, calculate the final temperature of the gas after it is done 2.4 times 10 to the 3 joules of work. So we just want to start out by writing out what we're given. So that's N equals 6 moles, and that the work is equal to 2.4 times 10 to the 3 joules. And the initial temperature is 27 degrees C, and our goal is to get the final temperature. So I'll write equals question mark. Great. So just to give an overview of what we're going to do to solve the problem, we're going to use the definition of work being the integral of P delta V to obtain the quantity P delta V. And then we're going to use that ideal gas law to relate P delta V to the change in temperature. So starting out with that, we can say that in the case of a constant pressure, that the work is equal to P delta V. So the integral reduces to that. And I'm not going to worry about signs, so it'll be implied that it's a magnitude. And we can set this equal to, and actually I'm going to use the same symbol to be consistent. And our delta T to find the change in temperature. So we can algebraically manipulate this to say that delta T is equal to P delta V divided by NR. And then we know that P delta V, which is the work, is 2.4 times 10 to the 3 joules, and N 6 moles. And then we need to use the ideal gas constant, 8.31 joules per mole Kelvin. Sorry, that's a little sloppy. And we can find that delta T is equal to 35.1 Kelvin. If you plug that into a calculator. And notice the units work out if you cancel those joules and those moles and put the kelvins on the top. And just as a note, since degrees Celsius is related to degree Kelvin by an additive 273, so you just add 273 to the degree Celsius to get the T final, then a change in temperature of 35.1 Kelvin is actually the same as a change in temperature of 35.1 degrees C. So to get the final temperature, we can just say that T final equals T initial, which is 27 degrees plus 35. I'm just going to cut the 0.1 because we only have 2 sig figs for the other temperature. Degrees C, and then that's equal to 62 degrees C. So that should be your final temperature.